guys, welcome to our lesson on congruence. When we think about the term congruent figures, we're thinking about figures that are exactly the same shape, exactly the same size. So keep that in mind as we go along. You may or may not have seen these terms before, so we'll review these. Motions that result in congruent figures are going to be your reflections. That is sort of a flipping around a line of symmetry. Translations, we're just moving the figure somewhere else on a grid. We're moving it left to right, up or down. Vertical shifts, horizontal shifts, that's going to be your translations. Rotations, those are our turns. We can turn the figure a certain amount of degrees. Motions that do not result in congruent figures, this is important. Dilations, that is going to be the one that does not result in congruent figures because dilations are going to shrink or stretch your figure. So they may be similar, they may sort of look like the same shape, but they won't be the same size once you're finished performing a dilation on a figure. There's some things we need to go over when we're talking about congruent figures and transforming a figure onto itself, and those are these here. When we're talking about reflecting a regular figure of some amount of sides across a line of symmetry, it will carry that same figure onto itself. Okay. If your shape has an even amount of sides, then the line of symmetry, the one that you'll be able to reflect the figure over and get the same congruent figure, is going to pass through two opposite vertices or through midpoints of two opposite sides. So two vertices or two sides. That's when the amount of sides is even. Okay, talked about this one. When you have an odd amount of sides, like a triangle, maybe three sides, then your lines of symmetry are going to pass through a vertex and a midpoint of the opposite side. So you'll notice one going through a vertex, those corners of your shape, and then extending through the opposite side to that vertex. Alright, one more thing to go over. When you're rotating a figure and you want to know what would carry this figure onto itself, that's going to be those rotations that turn 360 degrees divided by the number of your sides. So if you have a rotation of that amount of degrees, it's going to carry your figure onto itself. So we're going to keep all this stuff in mind as we take a look at some real examples. Alright, which transformations would carry this equilateral triangle onto itself? So thinking about all the information we just discussed, we notice that we have a triangle. That's the first thing that we will look at because that means we have three sides. So remember, we're talking about an odd amount of sides. So as far as reflections goes, remember we talked about your lines of symmetry will go through a vertex and the side opposite of that. So we can see one here. We've got a line of symmetry here, R. It's labeled R. And I know that that goes through the midpoint of the opposite side because I can see these tick marks here, letting me know that those segments are equal, which means that line R passes through the center of that side. So what reflection would carry this figure onto itself? It would be a reflection about the line R. Okay. And what about rotations? What kind of rotations would carry this figure onto itself? Well, we just need to find 360 divided by n. Our n is the number of sides, so we're going to calculate 360 divided by 3. Typing that in, we're going to get any rotations of 120 degrees will still carry this equilateral triangle onto itself in either direction. And we'll still have congruent triangles. Alright, let's take a look at another one. What about this figure? Which transformations would carry this six-sided figure onto itself? So now we have an even amount of sides. We've got 6. If we count them up, we can see again we've got a line of symmetry labeled here as T. When you have an even amount of sides, remember your lines of symmetry will go through two vertices as seen here. This corner and that corner is where this one passes. Or two sides, two of the sides. Alright. So reflections. We could definitely reflect this figure about the line T and carry it onto itself if we know that's a line of symmetry. Rotations, we could find some by taking 360 divided by n. Remember, we can always find them that way. 360 divided by 6, let's see what we get. 60 degrees. So a 60-degree rotation in either direction would carry this figure onto itself. And that concludes our lesson on congruence.